Welcome, everyone. It is an honor to be with you here today, our customers, our partners, our friends. We know how valuable your time is, and we deeply appreciate you spending it with us today. It is our goal to make every moment today worth your while. First, let me begin by saying a big thank you to our incredible team at Cockroach Labs that has put on this event and brought it to life. And next, I want to give another shout out to AWS, our strategic partner and the sponsor of today's event. Today marks an exciting milestone for Cockroach Labs, the launch of our ISV Technology Partner Program, the cornerstone of a thriving ecosystem we're helping to build to help customers solve their toughest challenges with best-in-class solutions that are powered by CockroachDB. By partnering with organizations who share our commitment to consistency and resilience and global scale, we're fueling the next wave of enterprise and digital innovation. Our first cohort of ISV partners delivers solutions in the identity and access management and authorization space. These 4 partners have demonstrated a deep commitment to building on CockroachDB's solid foundation. The ISV Partner Program offers technical and go-to-market benefits for the partners, and there are 2 tracks, one for embedding CockroachDB in their solutions and one for deploying alongside of it. So please join me in welcoming Ori, Teleport, Phase 2, and Offzed to the Cockroach Labs ecosystem. And check out today's announcement on our partners' webpage to learn more about this. I'm also excited to announce the expansion of our migration and modernization ecosystem through a new partnership with iSpire. This collaboration reinforces our commitment to simplifying the CockroachDB adoption and supporting our customers with their existing technology ecosystems. This is a complement to some of the migration tooling, our Molt tooling that we provide internally, and it expands our existing partner network. iSpire joins us as a leader in helping companies modernize their systems. So welcome to the team, iSpire. As Rob mentioned, RoachFest is global again with 3 events this year. We kick it off here today in London. And then for the first time ever, we are going over to India in September. And we'll wrap up the tour in Las Vegas in October, right next door to Oracle Open World. That's not just a schedule, it's a signal. Our reach is global and it continues to expand. And we're building this momentum together with you, our customers. Speaking of which, later today, you're going to be hearing from some of those customers, like SumUp, JPMC, Kaizen Gaming, and Booking.com. And you're going to hear from our partners, AWS and PwC. And you'll also be hearing from Cockroach's own Andy Woods about what's new in CockroachDB 25.2. If you were here this morning or joined us over lunch, we hope you enjoyed the workshops and the lightning talks. And as a reminder, our partners and sales engineer, they're still manning the booths. So please stop by, say hello, check out a demo. I also want to note that we'll conclude the day with a reception. I'm looking forward to seeing you all there. Come say hello, talk to me about anything. I love these conversations. So let's get started. The theme this year is simple but powerful, performance under adversity. And this theme reflects the criticality of both performance and resilience. But before we dive into performance under adversity, I want to reflect on the importance of resilience. You tell us repeatedly that resilience is the #1 differentiator of CockroachDB. It is what attracted you to CockroachDB in the first place. It's what keeps you coming back for more. Resilience needs to be deeply architected into a database. It needs to be engineered on a daily basis. It can't be bolted on as an afterthought. A database needs to be resilient to the environmental faults of the system the database runs on. It needs to be resilient to the application faults of the applications that run on the database. A database needs to be resilient to the changing workload patterns that are due to your applications, automatically rebalancing load to optimize performance. And a database needs to be resilient to the regular operations you need to perform on a database, such as a schema change to adapt to changing business requirements in your application. We achieve state-of-the-art resilience in CockroachDB through a combination of high availability and disaster recovery. Multi-active replication enables self-healing behaviors in the face of node, data center, and region outages. And advanced fault tolerance facilities enable seamless operation when disks and networks misbehave, as they so often do. Logical data replication enables advanced replication topologies, where you can have bidirectional replication from distinct clusters. Now, CockroachDB is architected and engineered to be resilient to all manner of faults, and yet disasters still happen. And defense in depth is just a fundamental requirement for mission-critical workloads that we support. And to that end, we provide a very robust backup and restore system, which we are continuing to innovate on with ever faster restore, an online restore which enables restoring cluster operations in the manner of minutes by serving data directly out of the backups rather than moving them physically into the cluster. We provide physical cluster replication for those applications that require near zero downtime in the face of a disaster. But state-of-the-art resilience is not a static target. The bar keeps on rising. Your expectations keep on rising, which was what was magical yesterday just becomes commonplace today, and we have to stay ahead of your expectations. That is our mission, to stay ahead of your rising expectations. Wall failover, leader leases, which Rob mentioned earlier, are two examples of recent resilience innovations. These weren't just innovations that came out of thin air. They came about from bidirectional communication with our customers, talking to you, understanding what your problems and your pain points were, and what we could do better. We wouldn't be here today without you, our customers. It is your toughest challenges that continue to drive us forward to shape our roadmap. It's important that we have a deep understanding of your challenges, and that we can bring that understanding in-house and enhance our products and to be able to test the real-world scenarios that you face. Let's talk a little bit about what's at stake here. This data that I'm going to share comes from our State of Resilience 2025 report, which I encourage you all to go read. And it's based on input from hundreds of engineers and operators across industries. And the numbers are fairly eye-popping. Among those we surveyed, an individual outage costs between $10,000 and over $1 million. That's an incredibly high number, and yet we have customers that tell us that an hour of downtime can cost substantially more than that. I encourage you all, if you're running business critical workloads, that you should know what this number is, like how much downtime costs you in your businesses. And even if you can measure those direct revenue costs, there's indirect costs that are sometimes very hard to estimate. These are reputational damages that can occur. Outages are frequent. On average, the respondents to the survey reported 86 outages per year. These are happening all the time. And these are on big companies, the scaled companies, not the ones that only have a handful of workloads, but the companies that have thousands of workloads. And outages are sustained. On average, companies experienced 324 minutes of downtime per week. That's nearly 5.5 hours of weekly downtime. In today's world, that number is no longer acceptable. Customers demand always-on experiences. Your business leaders demand speed and uptime. And regulators are increasing scrutiny around outages. And the message is clear. Resilience is no longer an aspirational goal or a nice-to-have. It is a business mandate. And of course, resilience is seeping into the headlines. Last year, the big story, as I'm sure you all remember, was CrowdStrike, a routine software upgrade which grounded flights, stalled hospitals all over the world. Just utter chaos, and chaos that is estimated to have cost $5.4 billion. That outage was a wake-up call that resilience deserves the same respect and attention as security. One fault, global impact. Stories like this are why we build for resilience at Cockroach Labs. The headlines, of course, they always cover the sensational outages, and yet the mundane downtime deserves our attention too. These are the everyday bumps caused by disk failures and network faults that add latency to your workloads, and also the bumps caused by planned downtime to perform upgrades and schema migrations. Planned downtime should be a thing of the past. We're living in the future today, and yet it still occurs. Preparation for this talk, I was trying to find an example of this, and boom, pops up on my screen. One of my service providers announced that they were going to have 12 hours of planned downtime to do an annual system maintenance test. And this isn't just a rare occurrence. This is you'll probably all experience something similar, or you're running businesses where you're still doing this. This is 2025. We can and should expect better. The technology exists to do so, to provide those always-on experiences. And CockroachDB can help you do so. Resilience is critical, but words alone are insufficient to convey the reality of a resilient database. We want you to experience resilience in action. Database vendors often tout performance benchmarks, and yet these are clean room numbers, obtained under idealized conditions. But as we all know, the real world is not clean nor ideal. It is messy and chaotic and dynamically changing. And performance benchmarks need to reflect these real world conditions. So we're introducing performance under adversity as a framework for understanding the combination of performance and resilience. Where do we start? We start with a baseline performance phase. This is what you typically see from a performance benchmark. There's usually a top-line throughput number combined with a latency number. And for most performance benchmarks, the goal is higher throughput, lower latency. But just simply one number of high throughput and lower latency doesn't really reflect what you need. You need stability, stable performance over time. And that's what you're seeing here. The blue line on this chart represents throughput, and it's stable. The yellow line represents latency. It's also stable. We're measuring P95 latency in the performance under adversity benchmark because tail latencies are important. With sufficient database operations for each of your workloads operations, all of your customers will experience the tail latencies. We've used TPCC as the baseline workload. And if you're not a database nerd, TPCC is this workload that models a business with warehouses and inventory and transactions. You know, it's a real world simulation. It's useful. The actual workload is unimportant. What is more important is what comes next. How does the performance respond when we introduced various adversity scenarios into the mix? And we've divided these adversity scenarios into phases of increasing difficulty. The first phase we've termed internal operational stress. And these are the kind of the everyday occurrences or the weekly occurrences that would occur. How does the system respond when a backup is being performed or schema change is being performed? Or you want to do a rolling upgrade in order to perform a security patch or do an upgrade to the system. Ideally, throughput should be unaffected. Latencies should have minimal impact. The system should recover to the steady state performance very quickly. And that is what you see here. Throughput nearly maintains that perfectly horizontal line, and you see just only the tiniest of blips on the latency. Moving on, we get to disk stalls. What is a disk stall? This might be an unfamiliar term to many of you, but it's a regular occurrence. These are gray failures that occur on network disks when a disk operation fails to return quickly. The term gray failure represents that these are not black and white failures where there's a clear indication of success or failure, but you do an operation and it fails to return quickly. Now, disk stalls are actually incredibly regular occurrences, daily occurrences when you're operating at scale, and particularly on cloud network block devices. A database needs to be engineered to handle these failures seamlessly. And thanks to the wall failover facility I alluded to earlier, CockroachDB handles disk stalls without breaking a sweat. Next up are network failures. We test both full network partitions and asymmetric network partitions. Asymmetric network partitions are fascinating because they're not something most people are familiar with. It's when one node or one machine can talk to another, but the reverse is not true, and they need to be specially handled in a database or in any system. And in the age of software-defined networking, using Kubernetes, for example, asymmetric network partitions happen surprisingly frequently, particularly at scale. And CockroachDB automatically routes around these network blips. And again, it takes these punches and just keeps on humming along. Next, we move on to node failures. CockroachDB is designed to survive node failures with zero data loss. It's been like that since the beginning. But it's also engineered to minimize the disruption of a node failure. You don't just want to survive with zero data loss, you need the system to come back quickly. And lead releases are a recent innovation in this area, which further reduce the impact of node outages. They further reduce the P99 latency impact. And in their demonstration of our commitment to continue to raise the bar on resilience. And then we move on to zone failures. A zone failure is akin to node failure, but it's multiple nodes failing simultaneously because, for example, the networking connectivity to a zone was taken out. Unlike a node failure, a significantly larger fraction of the nodes in a cluster just suddenly disappears. And it's actually sort of remarkable that we have databases today, CockroachDB being the prime example, that survive zone failures and just keep on ticking. And I want to note something. No human intervention was required in this test. There's no manual failover operation. There's no paging of an engineer in the middle of the night. CockroachDB automatically notices the failure, self-heals, and continues operation. And lastly, we get to region failures. These are the most severe type of failures. A very significant fraction of the cluster is taken offline. And latencies are necessarily affected by this. It's a severe disruption to the cluster. And yet, you'll notice the throughput is hardly affected. Performance under adversity is how you can sleep easily at night. Under highly adverse conditions, CockroachDB delivers stable throughput and minimal latency impact, and seamlessly self-heals. This isn't theory. This is what best-in-class resilience looks like. This is what our customers tell us they're experiencing today. Performance under adversity isn't merely about demonstrating resilience. Raw performance matters too. There's a need for speed. More specifically, there's a need for better performance efficiency. CockroachDB is a distributed SQL database, and one way to get more performance from a distributed SQL database is to scale it out horizontally to add additional nodes to a cluster. But you've told us you want more performance on the same hardware, and we've listened. Over the last 6 months, a crack team of Cockroach Labs engineers has been laser focused on performance efficiency, and the results have been dramatic. The 25.2 release that just came out is 50% faster than the 24.3 release from 6 months ago. 50% more throughput on the same hardware. This 50% improvement was measured on synthetic benchmarks in our labs. This is Sysbench and YCSB and TPCC. But now we're seeing this performance improvement translate to an initial set of customer workloads. Kind of the best part of this performance improvement is you don't have to do anything. There's not some new feature you have to adopt in order to get this. You merely have to upgrade. So we're eager for y'all to take 25.2 for a spin and report back what your experience is. Now, I can't guarantee you that you will see the same performance improvement as what we saw in the labs. I can guarantee you that we are not done in this area. We're already hard at work on further performance improvements. We're anticipating substantial additional performance efficiency gains in the 25.3 and 25.4 releases later this year. In aggregate, we expect CockroachDB to nearly double in performance between last November and this coming November. And that's an awesome achievement. So resilience and performance, they of course matter for today's applications. They're going to matter for tomorrow's applications. But what are the new needs of tomorrow's applications? Now recently, AI has taken over the conversation. I imagine every one of you has been talking about AI probably today and likely multiple times each day with your various colleagues. Last year, we saw the rise of AI chatbots and AI coding tools. And these developments, they heralded that the long-held promise of AI was entering a new phase. AI is no longer this dream of the future. It's here today, something that's happening now. This year, we're seeing the rise of something new, another phase of evolution in AI, and that's the rise of agentic AI systems. These aren't just smart assistants, they're autonomous. They plan, they act, they adapt over time. And they're starting to do real work for significant durations. What was minutes earlier in the year is now turning into tens of minutes, and pretty soon will be hours. What you're seeing on screen is the basic agentic AI pattern. Some of you might have seen this before, but this is the fundamental pattern of how AI agents work. A user interacts with an agent, asking it to do some bit of work, and then the agent loops, interacting with its environment. And when we say interacting with its environment, it's interacting with the database, an application, your application, possibly CockroachDB underneath, or some other database. At some point, after looping done numerous times, the agent finishes and returns in response to the user. So what does this mean for our data systems? What should you draw from this? And in short, there's going to be increased data pressure. So let's just zoom out for a second. Most applications follow this basic pattern. There's a user, they interact with an application, and usually there's a database underneath the hood, storing persistent state. And it doesn't matter if you're running a bank, a travel service, a food delivery app, a video streaming site. It's the same fundamental basic pattern. But agentic AI is introducing a new entity into this architecture. This is the world we're heading into. AI agents operating at scale, not as passive consumers, but as autonomous, active participants in the system. These agents, they query, they write, they analyze, they revise and loop, and they don't sleep. They don't pause, they don't wait for a human to click a button. In each of these lines, that represents a read or a write on an application, a transaction, a workflow checkpoint. Multiply that by thousands of agents out in the world, running in parallel. And the database becomes this central nervous system, gluing everything together, constantly queried, constantly updated. And there's an unfortunate truth here. Legacy database architectures weren't designed for this kind of scale pressure. They break under the volume, they lag, and they throttle. CockroachDB was actually designed for this moment to scale, elastically scale up under the load. It's designed for global distribution and always-on availability. Bringing us to scale again. Capacity planning. Any of you who have engaged in capacity planning know it is hard. Predicting future traffic growth is incredibly hard, and it's always been hard. You get capacity planning wrong, and either your user's experience suffers, or you've over-provisioned, and you've wasted a lot of money. You're burning cache. And that's where CockroachDB's elastic scale comes in. You can easily scale up when demand spikes. Now, such rapid growth isn't a new phenomenon. I'm actually showing you a chart. You see the dates here. This is from the beginning of COVID. This is a customer of Cockroach Labs, an education customers, that saw their demand spike 20x over the course of 6 months. And because they built on CockroachDB, they elastically scaled up the demand, and they were able to handle it. And if it wasn't for CockroachDB, they said we would have just been crushed under the load. And you're hearing more and more of these stories. Agentic AI is going to produce more and more of these stories. And it's kind of incumbent on us to be building upon scalable foundations. AI isn't just changing the scale equation, though. It's actually changing what databases need to do. And that brings us to vector search. So vectors, they're a new kind of data type that has arisen in prominence due to advances in AI. And you can think of vectors as numeric representations of concepts, of words, ideas, images, but these abstract concepts. But unlike traditional data, vectors exist in these very high-dimensional spaces. There's not one numeric value for a concept, but there's like 1,000 numbers in an array, and that's the vector. So why does this all matter? Well, AI researchers found something that was actually remarkably surprising, that these concepts represented by these vectors, they behave in this intuitive way. And that is, similar ideas end up close to each other in this very high-dimensional space. For example, what you're seeing on screen, the vectors for cat, dog, and wolf, they're all animals. They all sit near each other in this high-dimensional space, while the vectors for banana and apple, they're quite distant. And note that the visualization you see here is just for explanatory purposes. This graphic, it's depicting 3 dimensions. In practice, the vectors have hundreds or thousands of dimensions. OpenAI's vectors, they have 1,536 dimensions. Our poor human brains cannot conceptualize what that looks like, so we simplify. Now, vector search simply means finding the nearest neighbors in this very high-dimensional space. You might query for kitten and find cat nearby, or maybe even expand it out and find cat and dog nearby in this high-dimensional space. Vector indexing is what allows doing the vector search efficiently. And unlike traditional database indexes or full-text search, which they look for exact matches or structured patterns, vector search excels at identifying similar concepts. Vector search is becoming a core part of AI workloads, particularly something known as retrieval augmented generation, or RAG. Now, vector databases exist. You might have heard the term vector databases, but they're limited. You get vector search. AI workloads need more than just vector search. They need full-text search. They need faceted queries, transactional data. And today, you end up stitching all that together at the application layer, and that adds complexity. You have consistency and staleness headaches because the data isn't just managed holistically. So with CockroachDB 25.2, we're solving that. We've built distributed vector indexing right into the database. And not just any vector index, we built our own from scratch to solve the very difficult challenge of deeply integrating distributed vector indexing into a distributed SQL database. Our vector indexing technology is called C-SPAN, and it's based upon research from Microsoft and Google about how to do fast, incremental, disk-based vector indexing. And we use vector quantization to dramatically reduce the size of this index. And here's what C-SPAN brings to the table. You get high accuracy, you get the relevant results. Freshness, thanks to real-time incremental updates. You get scale, this is fully distributed. And you get resilience because it's built on top of our multi-active architecture and our fault tolerance features. And even better, vector indexing in CockroachDB is deeply integrated into our SQL optimizer and SQL execution engine. You get hybrid queries and you can express them naturally without hacking things together at the application layer. Vector indexing is now in public preview with CockroachDB 25.2, and I want you to try it out. Please tell us what your experience is and let us know how it's working and what can be improved. As we wrap up today, I want to bring it all together. Today, we explored what it means to deliver performance under adversity. In a world where downtime can be measured in tens or hundreds or even millions of dollars per hour, resilience is no longer optional. It's a requirement. And CockroachDB is built to stand up to the real-world chaos of distalls, network partitions, node failures, and even region failures, delivering stable throughput and minimal latency degradation, and seamless self-healing. But resilience alone, it is not enough. You've told us you need more speed on the same hardware, and we've listened. And CockroachDB 25.2 is 50% faster than it was just 6 months ago, and that's just the beginning. We're continuing to improve. We're pushing hard on performance efficiency. And we've looked ahead to tomorrow's AI-native applications and their needs. Agentic AI, a term you're going to hear increasingly frequently, is driving these new workloads that are larger and faster and more unpredictable. CockroachDB's elastic scalability ensures that your infrastructure can survive and avoid success disasters. It's scale without drama. And finally, we talked about the new frontier, vector indexing. With C-SPAN, we're embedding powerful, fresh, high-accuracy vector search directly into the database, alongside all that resiliency and scalability goodness that you already love. No bolts, no glue, just a single cohesive system powering the next generation of intelligent applications. Thank you for being here today. You are the reason we build, the reason we innovate, and the reason we raise the bar again and again. I'd love to connect with you as many of you as possible. So let's keep the conversation and build the future together. Thank you.